Landforms are exposed features of the earth and occur everywhere. From molehills to mountains to major tectonic plates, landforms have a varied range. The lifespan of the various landforms also range from days to millennia to aeons. Study of the nature and origin of landforms, particularly of the formative processes of weathering and erosion that occur in the atmosphere and hydrosphere, is known as geomorphology. Geomorphological processes continually shape the surface of the earth and produces sediments that circulate in the rock cycle. Geomorphologists study the three main aspects of landforms: form, processes, and history. Process geomorphology is the study of processes responsible for landform development. Weathering is a geomorphological process. Geomorphically significant processes involve production of loose, heterogeneous material covering solid rock called regolith by weathering and erosion. Transportation of that material, eventual deposition of that material. After our planet had Earth evolved a solid land surface and atmosphere, the water cycle and plate tectonic processes combined to create the rock cycle. Weathering, transport, and deposition are essential processes in this cycle. This chapter outlines the definition of weathering, agents of weathering, types of weathering, and erosion. Weathering. Try examining a rock in a gully or on a mountain slope, a riverbank, or at the seaside. At first, you will notice that the rock is solid. But if you examine closely, you will discover that they are ruptured. Some are ruptured more and some others less. In places, they even crumble away simply from the impact of your fingers. If you hit a rock with a hammer, whole chunks collapses into debris or sand. Did your notion of their strength somewhat change by seeing the hard rock breaking into heaps of fragments? A rock or a stone decays naturally into smaller particles by a process called weathering. Weathering is a slow, continuous process that affects all substances exposed to the atmosphere and is a vital earth process. A rock changes from a hard state to a softer and weaker state due to weathering and makes it get eroded easily. Due to weathering, rocks produce solid, colloidal, and soluble materials. These materials differ in size and behavior. Solids range from boulders, sand, and slate to clay. These solids are large, medium, and small fragments of rock subjected to disintegration and decomposition. Solutes are particles less than 1 nanometer in diameter. These solutes exist in molecular solution. Colloids are particles of organic and mineral substances that range in size from 1 to 10 nm. Some of the common colloids produced by weathering are oxides and hydroxides of silicon, aluminum, and iron. agents of weathering. What are the forces which destroy such hard rocks as granite, quartzite, and marble, which are used in structures built for long life? Or are these calculations unfounded? To a degree, yes. Buildings can be considered long-lived only when we compare them with the span of human life. Actually, they too gradually wear out, for they are subjected to the influence of the same natural forces as those which destroy rocks. We encounter these agents daily, but we do not have the slightest idea that they can destroy rocks. They are the heat, the frost, rain and snow, water and wind, and also modest plants and minute organisms. On hot days, the rocks are exposed to the blazing sun rays and they become intensely heated. You can verify this by touching one. At night, they cool down. These fluctuations in temperature from hot to cold and vice versa especially manifest in spring and autumn, when it is hot in the day and frosty at night. When the rocks become heated, they, like other bodies, expand. When they cool down, they contract. These expansions and contractions are hardly noticeable. However, when they are repeated day in and day out for hundreds and thousands of years, they ultimately make themselves felt. The adhesion of the rock's particles gradually weakens. The coarser and the particles of the rock, the more they weaken because the coarser grains shrink and swell more than the finer ones. The color of the rock is also an important factor. Black and in general dark colored rocks become heated and therefore swell more than the light colored ones, which reflect the sun rays better. You can improve this by placing a black stone and white one next to one another in the sun and touching them after some time. Water assists the temperature action. In rainy weather, the cliffs become wet. Porous and multi-cracked rocks absorb more moisture, while solid rocks absorb less moisture and then they dry again. This repeated wetting and drying is also harmful for grains adhesion. The weakening of grain adhesion finally leads to the grains crumbling apart. The rock loses its strength and breaks up into its components. The solid rock crumbles into loose sand. Even more effective is the water, which freezes in rock cracks and cavities. This happens in the autumn when frost follows rain, or in spring when on warm days the meltwater seeps into the rock and freezes at night. Moreover, the rain and meltwater penetrating into rock are chemically active as they carry gases absorbed from the atmosphere, oxygen and carbon dioxide. Oxygen is an active gas present in the atmosphere. It maintains the burning of fuel, causes oxidation of various substances entering into combination with them. Carbon dioxide is exhaled into the atmosphere by animals and plants. It is evolved during the burning of fuel in dwellings, fires, in car and aeroplane engines, in locomotive fireboxes, etc. Hence, the water precipitated from the skies as rain and snow, which falls on the rock and seeps into the cracks, is always charged with oxygen and carbon dioxide. This water exerts a more powerful effect on rock than the water in which these gases are absent. Plants also help in destroying rocks. Lichens colonize even every smooth rock. The wind carries their minute spores into the tiniest cracks, or they stick to a rock's surface during rain. They germinate and become firmly lodged. Together with moisture, they absorb from the rock the salts needed for the growth and gradually corrode the surface and widen the cracks. All plants injure rock because the carbon dioxide which they expel when dissolved in rain and melt water evolves carbonic acid, which, as we have already mentioned, stimulates the corrosive action of the water. Then the dead parts of the plant's stalks, leaves, root rot and form other acids which also accumulate in the water and corrode the grains. Thus, little by little, day by day, year by year, down the centuries, These negligible forces work at the destruction of the rock, at its weathering. How they work, we cannot see, but the fruits of their labor are seen everywhere. Continuous solid rock, which at first had only a few tiny cracks on its surface caused by temperature fluctuation or by the formation of folds, with weathering suffer more or less destruction. The initial cracks expand and their number progressively increases. Small and large fragments fall away from the corners and edges and pile up at the base or roll down the slopes, forming talus deposits. The smooth surface of rock becomes rough and corroded. Lichens cluster in some places, dents and crevasses appear at others, and elsewhere we see black or rusty stains. These forces heat and frost, dew and melt water, water seeping into the rocks and vegetation do, as it were, not only their work, but also help other forces of nature, the rain and wind. Water cannot wash anything away, and the wind cannot blow anything away from a smooth, newly formed rock, for it is too hard for them, and the grain adhesion is too strong. But from a rock subjected to weathering, the rain washes away liberated grains. The rain, collectively in runnels, gradually wears way notches in the rock. The wind disperses liberated sand and dust particles and breaks off decayed corners and carries them away or hurls them down slopes. The wind blows harder on a mountain top than in a valley or on a plain, and the higher the mountain, the stronger it blows. The blows against the most rugged summits and crests, where aided by frost and heat, it destroys the rock. If we linger for some time near a larger rock or sheer wall or on a sharp crest high up in the mountains, we can occasionally hear the loud reports of falling blocks or the noise of boulders sliding down a slope. When the wind blows, or after a rain, or on a quiet frosty night, or in the spring when the snow melts, this noise, which keeps clearing of the mountain's gradual and uninterrupted destruction, is heard more frequently. Types of weathering. Dear students, you now know about the agents that cause weathering. We will now proceed to learn about the different types of weathering and the factors which control weathering. Three prime groups of weathering processes have been identified. They are physical or mechanical weathering, chemical weathering, and biological weathering. Physical or mechanical weathering. This type of weathering refers to the group of processes such as frost bedding and volume changes of minerals that result in the mechanical disruption of rocks. For example, granular disintegration, exfoliation, joint block separation, shattering by changes in temperature or pressure. A significant component in mechanical weathering is fatigue. Fatigue is the repeated generation of stress by, for instance, heating and cooling in the rock. The result of fatigue is that the rock will fracture at a lower stress level than a non-fatigued specimen. The main processes of mechanical weathering are unloading, frost action, thermal stress caused by heating and cooling, swelling and shrinking due to wetting and drying, and pressure exerted by salt crystal growth. We will now discuss about each of the above mentioned mechanical weathering processes in brief. Unloading. The pressure on the rock is reduced when the surface material of the rock is eroded. This reduction of pressure allows the mineral grain to move further apart and creates void. This results in rock expansion and dilation. The dilation results in large or small cracks, fractures and joints that run parallel to the surface. These dilation joints results in rock falls and other kinds of mass movement. Lineages of weaknesses are formed due to the small fractures and joints along which crystals or particles may disintegrate and exfoliation may occur. Exfoliation is the breaking of rock sheets from the main rock body. Frost action. Water occupying the pores within a soil or a rock body expands upon freezing by about 9%. This expansion builds up pressure in the pores and causes physical disintegration of rocks. Frost weathering breaks the small grains and large boulders. The boulders are then broken into smaller pieces. This is an important process in cold weather conditions where freeze-thaw cycles are common. Heating and cooling. Rocks are not good at conduction heat away from their surfaces. Consequently, when the rocks get heated, the outside surface expands more than the insides. These thermal stresses causes disintegration of rocks. Repeated heating and cooling produces a fatigue effect, which augments thermal weathering. Wetting and drying. Some clay minerals swell, like smectite and vermiculite, swell upon wetting and shrink on drying. Alternating swelling and shrinking in combination with the fatigue effect leads to wet-dry weathering or slaking, which physically disintegrates rocks. Salt crystal growth. On evaporation, crystals may grow in saline solutions in coastal regions. This type of salt crystallization within the crevices of the rocks generates stress, which widens them and results in granular disintegration. This process is known as salt weathering. Chemical weathering. Chemical weathering refers to the decay of rock forming minerals by water, temperature, oxygen, hydrogen, and mild acid. Weathering involves a huge number of chemical reactions acting together upon different types of rock under the full array of climatic conditions. 6 main chemical reactions cause rock decomposition: solution hydration, oxidation and reduction, carbonation and hydrolysis. Solution. The process of solution or dissolution occurs when the mineral salts get dissolved in water. This involves the dissociation of the molecules and each ion is surrounded by water, though is mechanical rather than a chemical process. It is generally discussed with chemical weathering as it occurs in combination with other chemical weathering processes. Hydration. Hydration is transitional between chemical and mechanical weathering. It occurs when the minerals absorb water molecules on their edges without otherwise changing the chemical composition of the original material. Example, under humid mid-altitude climates, brownish to yellow soil colors are caused by the hydration of the reddish iron oxide, hematite, to rust-colored goethite. Oxidation and reduction. Oxidation involves oxygen combining with the substance. Oxygen dissolved in water is a prevalent oxidizing agent in the environment. Oxidization weathering mainly affects minerals containing iron. The reaction occurs when the oxygen dissolved in water comes in contact with iron containing minerals. This reaction distorts the neutral charge of the crystal lattice, sometimes causing it to collapse and making the mineral more prone to chemical attack. If the rock or soil becomes saturated with stagnant water, it creates oxygen deficiency and reduction occurs. Reduction is the opposite of oxidation, and the changes it promotes are called gleying. Carbonation. Carbonation is the formation of carbonates, which are the salts of carbonic acid, H2CO3. Carbonic acid attacks minerals, forming carbonates. Carbonation dominates the weathering of calcareous rocks like limestones and dolomites, where the chief mineral is calcite or calcium carbonate, CaCO3. Hydrolysis. Hydrolysis is the main process of chemical weathering and can completely decompose or drastically modify susceptible primary minerals in rocks. In hydrolysis, water splits into hydrogen cations H+ and hydroxyl OH- and reacts directly with silicate minerals in rocks and soils. Biological weathering. Some organisms attack rocks mechanically or chemically or by combination. Plant and tree roots growing in bedding planes and joints of rocks have a biochemical effect. They put pressure as they grow, leading to rock fractures. In coastal regions, marine organisms like bivalve molluscs and clinod sponges bore into rocks, like for example in tropical limestones. Under some conditions, bacteria, fungi, algae and lichens may chemically alter the mineral in the rocks. The rock minerals may also be removed, leading to biological rock erosion. Humans also are responsible for biological weathering. They disrupt soils by detonating explosives, seal the soil in urban areas with concrete, and also the agricultural practices greatly modify soil and weathering process in many regions. Erosions and transportation. Erosion is the removal of weathered rock material downslope and away from their original site of weathering. Erosion processes are driven primarily by the force of gravity, which may be aided by a flowing medium such as water, example rivers, and ice, example glaciers, or gravity may act alone, example rockfalls. Wind can also remove weathered materials, example deflation. During transportation of the weathered rock materials, the angular particles commonly abrade the surfaces over which they pass, wearing away and lowering the rocks. Weathering and erosion gradually shape and polish Earth's rock into works of art and then wash the remains into the sea. Weathering and erosion processes are definitively independent but not exclusive. Weathering is the mechanical and chemical hammer that breaks down and sculpts the rocks. Erosion transports the fragments away. Erosion processes. Erosion processes are usually considered under 4 distinct categories. Mass wasting, the processes that occur on slopes under the influence of gravity, in which water may play a part, although water is not the main transporting medium. Fluvial, the processes that involve flowing water which can occur within the soil mass, example soil piping over the land surface, example rills and gullies, or in seasonal or permanent channels, example seasonal streams and rivers. Wind, the processes that involve the action of rapidly moving air streams in dry areas, which can be cold or hot deserts. Glacial, the processes that involve the presence of ice either in the soil, example solifluction, or as the transporting medium, example glaciers. In some arid and desert tracts, wind has an important effect in bringing about the erosion of rocks by driving sand, and the surface of sand dunes, not held together and protected by vegetation, is subject to erosion and change by the drifting of blown sand. This action erodes material by deflation, the removal of small loose particles, and by sandblasting of landforms by wind-transported material. Continued deflation of loose particles from landforms leaves behind large particles more resistant to deflation. Wind action transports eroded material above or along the surface of the earth, either turbulently, particles moving in all directions, or by laminar flow, in which adjacent sheets of air slip past one another. The transportation of wind-eroded material continues until the velocity of the wind can no longer sustain the size particle being transported, or until the wind-blown particles collide with or cling to a surface feature. Conclusion. Let's now sum up the information that we have studied in this chapter. Weathering is the breaking down of rocks, soil and minerals through contact with the atmosphere of the earth. Weathering gradually weakens rocks and eventually produces new geological materials, rock fragments, sands, slits and clays that are more stable in the new environment. Weathering generally produces finer and less dense rock materials and weaker, more porous and permeable rock masses. 3 important classifications of weathering processes exist: physical, chemical and biological weathering. Mechanical or physical weathering involves breakdown of rocks and soils through direct contact with atmospheric conditions such as heat, water, ice, and pressure. Chemical weathering involves direct effect of atmospheric chemicals. Biological weathering involves breakdown of rocks due to biological produced chemicals. Erosion involves the movement of rocks and minerals by agents such as water, ice, snow, wind, waves, and gravity. Weathering does not involve movement and occurs in situ and should not be confused with erosion. The term erosion refers to the general wearing down and molding of all landforms on the Earth's surface, including the weathering of rock in its original position, the transport of weathered material, and erosion caused by wind action, fluvial processes, marine processes, and glacial processes. Bits of sand are picked up and carried off by the wind, which can then blast the sides of nearby rocks, buffing and polishing them smooth. On the seashore, the action of waves chips away at cliffs and rakes the fragments back and forth into fine sand.